Now we have the values of half skip distance and full skip distance. Now let's try to mark it on this piece of our test specimen. So how we are going to mark it? We got half skip distance as 16.3. So I'll just take this one, put it to 16.3 approximately. 16.3. Yeah, I think this one is 3. And then from the center point, from the center line, we just mark a line somewhere here. This is your half skip distance. Same way here on the center line, just mark half skip distance. Then go for the full skip, that is 32.5. So I'll just take this one and put it to 32.5. 32.5. Yes, this looks 32.5. So I'll mark it over here and mark it this side. Same way you have to mark it on the other side because you're going to check from both sides. So mark full skip distance here, full skip distance here, and let's try to mark the half skip as well on the other side. Now you can just take a ruler and just make it a complete line. Just mark it, it will be easier for doing the test. Now I have some set of lines. I can see clearly. Yeah. Now this one is half skip distance. This one is also half skip distance. This is full skip distance. This is full skip distance. Meaning of this full skip distance is if I keep this probe exactly over this full skip distance, I mean this line, if I just keep this one on this line, then the sound wave will travel from here to here. It will come outside at this point. So let's try to open the instrument and calibrate it. So whenever you're doing any experiment, the first thing you'll do is calibrate the machine. So switching it on, switch on the machine. Today we'll be using a small V2 block. It's easier to calibrate, it's portable for calibration. This is a normal probe. How do I remove it? This is LEMO cable, it's easy to remove. Let's plug in this one. Now for calibration, change the material velocity because now we are using shear velocity, I mean shear waves. So velocity will be less for shear wave. This is something like 3250. So we have set it to 3250 because the shear wave velocity in steel is 3250. Now let's go for P delay. We'll just make it to 0. So we're just starting fresh. Everything is 0 now. Maybe you can see the glare. I don't know how to remove the glare. No. Still you have some glare. Okay. Now after this one, You have the probe ready. Now we'll go for finding out the index point. So if I just put it somewhere here, you'll get a signal. But what range should I put? I think 150 is good. Let's put some oil over this piece of calibration block and just try to see some peak. Okay, because the range is bigger, I can see so many peaks. So we can see if I'm facing the probe towards the smaller side, that means I should get a peak at 25, because this is the 25 radius. This longer side is the 50 radius. So you can see, yes, this is the peak. So how can I get the exact value for the peak? I have to use A gate, going for A gate setting, just moving the A gate back here. Let me increase the width of this one. I think this one is good enough. Let's go back. So what I'm trying to do is I'm just trying to move it to find the biggest peak. So I'm just looking for the highest peak by moving back and forth. So somewhere you'll get an highest peak. So when you're trying to search for some defects or some higher peaks, try to rotate as well. A little bit of rotation makes your work very easy. So this value should be 25. Oh, my A gate, I need a bigger A gate. Should start somewhere here. Okay, yeah, that's good. Base value, P delay. So somewhere here I'm getting the highest peak. The highest point is this one. So I'll try to reduce it and I'm just making this number as 25. So this is close enough. This is 25. Now I want to check the probe is correctly calibrated. How do I check it? Just turn it. Now I'm trying to send the sound wave towards this bigger end, and I want to see if it's coming at 50. So you see, I get a small peak. I'll just move the A gate to know the value of, what is this value? This value is approximately 50. Yeah, it's 50. Now our machine is calibrated. Now the next step is, what range value should I set it? So you can see we calculated full skip distance as 32. So range should be more than this full skip distance, because we want to see actually two legs. So what I'm going to do, I'm going to add something like 12.5 mm, half of the inch, to 32.5, just some extra to get some extra length. So this is 4, 5. So my range should be at least 45 millimeters, so that it covers the complete area. So what I'm going to do here is select the base setting, go for the range. I'm just making it smaller. I can make 45, 50, it's okay. You can set it to anything. But this is the maximum thing what you're going to measure over here on this plate. So let me just move it back. Okay. Now let's go for the scanning. For scanning, always put some oil over the plate. It's easier for scanning. So I'll be starting from this point. What I'll be doing is I'm just going back and forth to find some defect. So if you cannot find some defect, try to increase the gain value. Now it'll be easier. Here you can see. Just we'll try to look for some peaks. I got some peaks over here. So this is a defect now. At what distance I'm getting this defect? So how do I mark it? Just use the A gate, move the A gate over here. Just you can see. Just try to get the maximum peak where I'm getting over somewhere here. I'm getting the maximum peak. Now I'll just take a note. That's at sound path of 20 millimeter. I got a defect. I'm just making a note on the paper. This is our first defect. And you can even get the point where you're getting the defect. So you have to measure everything, all the details. So at what point I'm getting it? If I take the top side as my reference axis, so I'm getting this defect at 34 mm from the top side. From top side 34 mm. Later on we'll be using this one to make a report. And from the center axis to the index point, I'm just measuring the length. It's something like 22.2. So from index point to center point, 22.2 millimeters. Now let's go for other kind of defects. You see one more defect over here. Yes, you have one more defect. Let's move this one. Okay. So you have one more defect at 36.7 millimeter. Now if I see this from the top side, it's the center of the probe. This is 45.5 millimeter. And if I just calculate the index point to the center point, what is the distance? I'm having something like 24 millimeter. Same way, just continue. We got one more peak here, some small peak, some small defect. One more defect you can see over here. Let's try to get this defect. Okay, same thing. We got 24.33. Measuring at what distance from the reference point. So this is at something like 69.5. 69.5 distance from of the index point from the center. Just see over here, and it is same. I think it's 21. Distance is 21. Now just see, get same kind of defect. It's completely from this point to this point. You have a defect here. You can actually measure the length of it. The resistance starts here, and okay. I need more oil. So the defect starts here and ends somewhere here. So it's starting at 69, ending at this point. So it's ending at 93 93. So it's ending at 93. We'll see for the other defect as well, what you've seen before. Other defects are not lengthy defects. This one is lengthy. Maybe just 5, small defect, 4 to 5 mm. Okay. Now, please think carefully that you are trying to scan from full skip distance to half skip distance. You have to cross the half skip distance and you have to cross the full skip line to get all kinds of defects. Just you can see how I'm scanning it. I'm just moving back and forth and just moving towards this side so that everything is scanned. Same way on the other side, you have to scan, put some oil and scan it. You can see some defect over here. Yeah, this is a defect. So we got one more defect at 36.82. Starting point is something like, it's not easy to handle it. Let me just get again the same defect. Yes, yeah, this one is a defect. So approximately it is from the distance of 14. It's starting from 14. It's going towards, yeah, I think it's a small defect, only 1 or 2 mm. So I'll take from 14 to maybe 15. Yes, 14 to 16. Defect length is 14 to 16. You have one more defect over here. I think it's almost the same kind of 37.7 millimeter. And if I take the measurement, it's from the center is 33. And how long is the defect? If I just see, it's ending somewhere here. The defect size, we'll have one more experiment on defect sizing with a normal probe later on. But this is the crude way of doing it. It's actually not the correct way of defect sizing. And so on, just try to check it back and forth, back and forth. You got some defect over here. So this way you're going to check it. So let me just increase the gain. You can see if I increase the gain, the peaks become bigger. Yeah, this looks promising. Now for defect sizing, you can see I'm just increasing the gain. You can see the peak is increasing and then decreasing. So try to set the maximum peak. Let me just increase the gain size. Yeah, something like 80%. Okay. Now, how can I get the size of a defect? Size of a defect, you start from 50% of the peak and you end at 50% of the peak. Like you're starting here, this is 50%. Take the reading, then move the probe till you reach the other end of 50%. That is how you calculate the defect size of it. We'll have more discussion on this one in the theory class with some video and animation. So how you're calculating is, you're trying to look for this peak. I'm just going for this peak. This is something like at 80%. Now, if I just move it, it becomes smaller. So if I want to measure the size of this one, I have to measure this size from here, from this point, move it till it reaches the maximum somewhere here. Sorry, I think I lost it. Yeah, somewhere here. So this is 40. Then if I move it, it's becoming 80. Oh, it's becoming too much high. So try to get the peak. After getting the peak, make it to something like 80 or 90%. Now, how we are measuring this one is, we are measuring from 50% of the signal to 50% of the signal for measuring the length. What is the size of the defect? You can see on the bottom side, I'm trying to measure the size of the defect. So I'm taking it 50, trying to move it, get a bigger value, and move it further away to get 50% of the signal again. So this is how you will be testing, you'll be getting the defect size. Now, I think we can stop here. We can make a report in the lecture class. So